Hello everyone, today I will introduce the differences in porting guide from the RTL8762C to the RTL8762E. Here's the general catalog of the course, divided into 4 modules, which are the introduction of the RTL8762E, the feature comparison with the RTL8762C, the SDK module comparison, and the porting guide. First is to briefly introduce the RTL8762E chip. This introduction is divided into basic properties and the introduction to the IC structure. The RTL8762E supports Bluetooth 5.2 with ultra-low power consumption, 40 MHz ARM Cortex-M0 Plus processor, large flash, and SRAM, flexible GPIO design. It's widely used in remote control, smart home, mesh, low-cost wearable, smart healthcare, smart meter, and smart lock. Here are the general features and core parameters of the RTL8762E series, including supported functions and features of the M0 Plus core. Here are some metrics and peripheral interface information for RF. The RTL8762E series has these types of packages, which you refer to when designing and selecting. The architecture of the RTL8762E is shown in the figure. The interfaces mainly include RF, power clock, GPIO, and peripheral interfaces. The second chapter introduces the feature comparison between the R8762C and E series. This table lists some of the differences between the two in terms of protocol: CPU, flash, RAM, security, ADC, DAC, and PDM. Among them, RTL8762E supports Bluetooth version 5.2, and RTL8762C supports version 5.0. Both CPUs are based on the M series core architecture. The C series is M4, and the E series is M0+. For RAM space, the RTL8762C has 160 kilobytes, while the RTL8762E only has 104 kilobytes. For the ADC, the C series has 2 bits, and the E series is 10 bits. The table on this page lists some of the support for peripherals such as SPI, I8080, and I2C, etc. There is little difference between the two overall, but E series does not support the I8080. Next, we will introduce the third chapter, with differences of SDK modules. This chapter is divided into 2 parts. One is the differences in the stack part, including difference in program, file path, project path, API, and upper stack configuration. Then the other part is the introduction of the difference between I/O and peripherals. In the RTL8762C, the upper stack is included in the ROM, and there is no need to burn the upper stack image file. In the RTL8762E, the upper stack is separated from the ROM, and an independent upper stack image file is required to be burnt. For more about the RTL8762E upper stack image file, please refer to the documentation, link given below. Here's the second part of the stack, differences in the upper stack file paths. The file path of the RTL8762C upper stack is in the bin directory of the SDK. The upper stack file path of the RTL8762E is under SDK bin upper stack image upper stack XX. In addition, there are a few points to note. The first is that in the RTL8762C, if you want to use LE advertising extension functions, the app needs to include gap bt5lib. The RTL8762E supports the LE advertising extension functions by default. Upper stacks with different configurations need to include the corresponding gap utils.lib file. Finally, the RTL8762E upper stack will additionally provide upper stack config.h images files for the app to use. Here's the third part of stack, the difference in engineering configuration. When using the RTL8762E, the app needs to add the path of the upper stack config.h file to the include path. Here's the fourth part of the stack API differences. The differences in API usage of the RTL8762C and the RTL8762E can be referred to in this table, including the three APIs of GAP vendor CMD REQ, GAP RAM bond sign key flash, and GAP RAM bond sign CCCD storage. Upper stack provides upper stack files with different configurations, which are represented by upper stack _A_B. The following is the introduction of A and B. A indicates that the upper stack file with different configurations support different Bluetooth technology features. If multiple versions of upper stack files contain the same A values, the Bluetooth technology features supported by these upper stack files are the same. For specific support for Bluetooth technology features, please refer to the upper stack config.h file. B means that the upper stack files with different configurations have different performances. By default, the upper stack is configured as flash code, and the throughput optimized version of the upper stack files will be configured part of the code as RAM code. For the upper stack image currently provided by the RTL8762E, the space allocation can be seen in the following table. Next is the macro definition corresponding to the supported Bluetooth technology feature given in the upper stack config.h. 0 means that the feature is not supported. 1 means that the app can call the corresponding API when the upper stack supports a certain feature. For example, the upper stack FPT-LE read chan map is supported, and app can also call the interface LE read chan map. The following is the second part of the SDK module, introducing some differences between I/O and peripherals. Here is a list of peripherals, including ADC, codec, GDMA, SPI, pad, etc. Next, we will introduce the difference between the RTL8762E and A762C when configuring them in software. There are several points to pay attention to when transplanting or reading the ADC project, including these 8 parts. 1. When transplanting the RTL8762C ADC project to the RTL8762E, it is necessary to pay attention in replacing the B2 ADC lib.lib file in the project with ADC.lib. 2. The RTL8762E ADC has added the function of averaging the sampling rate value area by hardware. 3. The RTL8762C ADC has 8 channels for sampling external voltages. 4. The RTL8762C sampling accuracy is 12 bits, and the A762E bits are 10 bits. 5. The timer channel used by the hardware timer trigger of the ADC of the RTL8762C is timer 7, and the RTL8762E is timer 2. 6. Then this table describes some differences in the definition of the ADC in its type def structure. The 7th is some of the differences in define. And finally, the 8th is the interface name differences for the API. You refer to it when writing code or reading. Next is the difference of codec, which mainly has 3 parts. One is the RTL8762C / the RTL8762E code mic is the same, only contains 1 channel. The RTL8762C / the RTL8762E codec sampling rate range is the same, from 8 kHz to 16 kHz. The DMIC clock frequency parameters are different. The RTL8762C is 500 kHz to 4 MHz, while the RTL8762E is 312,500 Hz to 5 MHz. Here is the difference of GDMA, which is divided into 3 parts. The channel of the RTL8762C is 0 to 5, and the channel of the RTL8762E is 0 to 3. Under multi-block transmission and scatter-gather transmission, the channel RTL8762C and E use is also different. You can refer to this table. The last is the block size. The maximum transmission block size of the RTL8762C is 4095 and E is 65,535. The differences between SPIC, PAD, and LPC are listed here. The first is SPI. The RTL8762C and E have no additional SPIC for customers to use. Then there's the PAD part. There is no difference between these two. Then there's the LPC part. The LPC voltage comparison interrupt of the RTL8762C cannot be used under DLPS to wake it up. Instead, you need to set the LPC comparator value with the default one and interrupt and wake up the RTC interrupt. The RTL8762E has CPU and VIC and the DLPS wake up switch, while the RTL8762C does not. You can refer to the following two functions. The differences between the RTC, SPI, and timer are listed here. The RTL8760E can set the interrupt bit of the RTC wake up separately. You can refer to the WK function. For SPI, the maximum SPI clock of the RTL8760C and 762E is 20M, which can be passed through the function RCC SPI clock config to switch. When using PWM, the RTL8760E adds bypass dead zone, emergency stop interface. You can choose the clock source of the dead zone, so that the control time of the dead zone has more choices. There are three functions for reference below. The RTL8762E lacks two sets of timers, timer 6, timer 7. The RTL8762C has two sets of timer 2 and timer 3 to support PWM complementary output, while the RTL8760E only supports timer 2. This page lists the differences between UART key scan and I2S. Some special applications, for example when the GDMA plus idle interrupt receives data with a fixed length, the RTL8760E needs to clear the UART FIFO before re-enabling the UART int args idle interrupt, but the RTL8762C does not. Compared to the RTL8762C, the RTL8762E has only one set of UARTs that can be used by the customers, and the usage message is the same as that of the RTL8762C. For key scan, in manual scan mode, the RTL8762C will only generate an interrupt when the key is scanned, while scan end of the RTL8762E will generate an interrupt regardless of whether the key is scanned. In addition, the RTL8762E has added key scan manual scan mode, which is triggered by the key scan, or control the corresponding bit 0x08 to trigger the scan. For I2S, A760E has only one set of I2S. The following are the differences of IR. The IR of the RTL8760E supports DMA, but the RTL8760C does not. The initialization of the driver of the GDMA function needs to be used. The RTL8760C needs GDMA related configuration. Refer to the following four examples. TX DMA enabled and ARX DMA enabled needs to be enabled, and set the level of TX and ARX. Finally, pay attention to the unit setting of the frequency. In the driver initialization, the RTL8760C infrared carrier frequency is in kHz, and the RTL8760E is in Hz. As you can see in the carrier frequency parameter of the RTL8760C needs to be configured as 38, and the 8760E needs to be configured as 38,000. The RTL8760E adds RX edge trigger interrupts, and read the IR RX counter value in real time. For I8080, the A760E series does not support this function. The last chapter introduces the differences in the transplantation of the PxP project. This part is divided into 5 parts, namely project file transplantation, DLPS operation timer, app configuration file, and instructions for packaging and burning. The first part of this chapter is an introduction to migrating project files. It is divided into 6 steps. First, copy the PxP folder under the SDK/port/evb/directory in the RTL8762C project into the SDK/port/evb/directory in the RTL8762E project. Then you need to adjust the SDK/port. Some files in the evb/pxp folder are divided into the 5 steps of A, B, C, D, E. A. Copy the 4 files in the original RTL8760E project into the SDK/port/evb/pxp folder, among which the app.sct file in the SDK/port/evb/pxp/mdk folder. B. B. Create a new folder MDK under the SDK/port/evb/pxp/path. Move the 5 files in the figure below to the MDK folder. C. Replace all // contained in the following 2 files in the SDK/port/evp/pxp/mdk folder with // Adjust the size of the app global size in the memconfig.h file as needed. And finally, E. The upper stack configure section in the OTP config.h file needs to be modified according to the specific usage. If the bt stack config init function is not used, the bt stack config enabled macro definition needs to be cancelled. Then proceeds to steps 3, 4, 5. Use flashmap tool and np tool to generate the required flashmap.h file, and replace the flashmap.h file in the sdk/board/evb/pxp directory. The upper stack in the RTL8762E is a separate bin file, which needs to be downloaded to the flash, occupying 144 KB space. Therefore, 144 KB space needs to be allocated to the upper stack image when configuring the flash layout. Refer to the flashmap.h in the RTL8762E. 4. Copy the SDK/source/app/pxp folder in the RTL8762C, the same directory in the RTL8762E project. 5. Open the project and manage the files in the project according to the following table. Note the table on the right. Blue represents the path files that needs to be changed. Green means the files need to be deleted, and yellow means the files need to be added. The last step is step 7. Device is changed from ARM CM4 FP to ARM CM0P MPU. The following is the configuration method of DLPS mode. DLPS has 3 configuration steps. The first one is modifying the corresponding content in the current project according to the content of the DLPS module config module in the original RTL8762E port.h file. The second step, in the power manager init function of the main.c, modify LPM DLPS mode to platform DLPS PFM, and modify the relevant registers, that is, modify the AON register related content in the system handler function of the main.c file. Bit 7 is modified to bit 15. 0x2b is modified to 0x2a, and temp value is modified from uint8t to uint16t. Next is a description of the time module. Time is relatively simple. The time in the RTL8762E only contains time 0 to time 5. The time 6 is used in the original SDK needs to be changed to time 5. Here are some instructions for the app configuration file. For app, the following 5 header files need to be paid attention to. The first one is flashmap.h. When configuring the flash layout, it must be synchronized to the flashmap.init, and use flashmap generate tool to ensure consistency. For board.h, the board level configuration represents IO DLPS related. Then there is OTP config.h, which is responsible for updating the OTP configuration in the app, maintaining all other configurations that can be updated in the app except the stack. Memconfig is responsible for the memory configuration. Upper stack global size must be set according to the version of upper stack image used. Different upper stacks occupy different sizes of different data RAM. Please pay attention to the upper stack release document and its description. App global size needs to be adjusted according to the project application for more memory configuration. Please refer to the RTL8762E Memory User Guide. The last is the SCT file of the project link, which is related to the memory configuration. App data on address in the SCT file in the RTL8762E is changed to generically call app global address and memconfig.h. In cache data on address is also changed. The last part of PxP porting is the precautions for packaging and burning. When the RTL8762E uses np-pack tool to package or use np tool already download mode to burn files, it needs to package or burn 6 files. ROM patch image, OTA header file, secure bootloader image, upper stack image, app image, and system config. The upper stack image is the .bin file in the SDK/bin/upperstackimage/upperstack00 directory of the RTL8762E project. Thank you. Have a good day.